Welcome everyone to the AI for Climate Global Forum and the AI for Net Zero thematic track. We are pleased to open this track with the fireside chat leveraging AI for clean energy and GHG mitigation. I would like to welcome our very special guests, Priya Donti, co-founder and chair of Climate Change AI, and Andrés Fernández, climate risk and ESG manager at Hartree, who will be engaging in a really interesting conversation on the role of using AI systems to power clean energy and mitigating GHG emissions. Priya Donti is a co-founder and chair of Climate Change AI, an initiative to catalyze impactful work in climate change and machine learning, and also a PhD student in computer science and public policy at Carnegie Mellon University. Her work focuses on machine learning and forecasting, optimization, and control in high renewable power grids. Specifically, her research explores methods to incorporate the physics and hard constraints associated with electric power systems into deep learning models. Priya is a recipient of the MIT Technology Review Innovators Under 35 Award, the Civil Scholarship, the U.S. Department of Energy Computational Science Graduate Fellowship, and Best Paper Awards at several institutions. Now, I'm gladly going to introduce Andrés Fernández, who has 10 years of relevant experience working on sustainable topics ranging from environmental, financial, and political aspects, mostly related to the energy and transport sectors. He has a technical academic background within chemical engineering and economics, which he completed with working within policy and international organizations such as IRENA and the European Commission. He also ventured into agricultural venture and education consultancy. His work on drafting policy recommendations based on qualitative and quantitative evidence, and has been advocate and critic of the clean energy transition. In terms of AI, he has worked with connected intelligent transport systems, remote sensing to quantify the impact of desalination plants and power plants on water systems, and has evaluated the potential of AI on extractive industries and energy systems. I'm so glad to have you both here. Priya, Andrés, thank you for joining us. The microphone is all yours.
Thank you for that kind introduction. Priya, it's an honor to have you with such a wide-ranging experience. When we talk about AI, at least in my experience talking with different stakeholders, it's very difficult, right, to describe what AI is, and different people have different understandings. They think of Terminator, they think of different type of movie scenes. So I'd like to kick off this panel with a quick snapshot description in a nutshell. What is AI for you? So that we all start from the same page and we understand, we have a common understanding as we move forward in this panel of what AI is.
Awesome. That's a great question. And thank you. So happy to be here with Andrés and Lucia and the rest of the team. To start, I guess artificial intelligence is obviously a very, very broad term, and it refers to any computational algorithm that performs a complex task. And usually these are tasks that are associated with human intelligence in some way. So things like speech or perception or reasoning or vision or something like that. Now, within artificial intelligence, there are many different kinds of techniques. And one sort of big category of techniques here is machine learning. So machine learning it refers to any technique that learns from a large number of examples or data and extracts insights from that. And this happens in a large number of forms. There are versions of machine learning that look at a fixed data set, like analyzing a large number of images to try to get some kind of insight on those images. There are also versions of machine learning that are on some kind of system, like an electric power system, and they're operating on that system. They're getting more examples about if I operate this way, what happens. I get more and more examples that way, and then I can figure out how to interact with that system. So this notion of learning from data can take a lot of different forms, but this is what people mean when they say machine learning, an algorithm that can learn from data. And these days, machine learning is actually a relatively predominant paradigm within artificial intelligence.
You mentioned this word human, right? Often AI and human, the sort of boundaries are sort of blurred between AI and human interactions, human judgment. So my next question is, how can we judge AI? In other words, can anything be AI? Anything that seems human, vision, logic? Is there sort of like grade to that? And how can we say that is something good AI versus bad AI? The same thing is there's good human interactions, bad human interactions. Is there someone who evaluates it? Are there exams to say, okay, this AI is worthwhile, or no, this AI is really harmful for society? Can you guide us through this evaluation process of AI?
Absolutely. And this is, a great question. So when I sort of defined AI, you'll notice that I said complex tasks, often those associated with human intelligence, but not always, right? There are many kinds of complexity that an AI algorithm can try to tackle. So for example, thinking about my own work, I focus on how do you forecast, for example, electricity demand or solar power or wind power ahead of time so that you can optimize an electric power system based on that. This is not something that we usually judge a human's intelligence on. I don't say, Andrés, can you tell me what the solar power is going to be like tomorrow, right? But there's some level of complexity to that task because there's a lot of data and a lot of factors that really affect how much solar power is produced. So I think this question of how do you judge an artificial intelligence algorithm is really asking, for what purpose have I employed this? Is it satisfying that purpose? And that requires somebody sitting down and saying, what is the objective? What am I actually using this for? And then also, how does that objective fit into the broader context and the broader system? One thing about AI and machine learning is that these techniques accelerate the systems in which they're employed. So for example, if you use AI and machine learning to optimize a market, and that market has a certain objective of maximizing profit, then your machine learning algorithm will do a really great job maximizing profit because that's what you've told it to do. But then the question is, well, when we're thinking about climate change, when there are lots of goods and services that produce emissions, and we also want to reduce the emissions of the system, if we haven't told the machine learning algorithm that's what it needs to do, it won't do that. So this is why I say judging success, not just in terms of what is its performance on the task you've actually given it, but what does that performance mean? What is the context of that performance and how does that affect a broader system? And I think this feeds into your question of what is good AI or bad AI, right? This question of how does our use of AI either accelerate or fix certain sort of issues that may exist in society. So for example, if you are implementing AI in a way that is only accessible within the global north, then your AI algorithm is, by virtue of its use, for example, accelerating the digital divide between the global north and the global south. So I think it's not just about, is this algorithm doing the thing I asked? But again, also, how does that use of the algorithm change how society looks? And is that what we want?
So that's exactly what I was leading to. Sort of, when we talk about transition, reducing emissions, there's this concept of just transition, and really being aware of sort of the sort of learned lessons that we have from our past of bias, of lack of inclusion, lack of gender awareness when we design algorithms. So I'm interested to know, within your work, how can you ensure that these concepts, these elements are taken in consideration when we develop AI that perhaps, could be only focused on a certain context, certain type of people, certain markets, and is not really applicable elsewhere?
Yeah. And I think a big thing is, as you mentioned, right, inclusion and participation, and beyond that, capacity building. So in the short term, right, I think any AI practitioner can think about, for example, whose problems am I solving? Am I solving the problems of a large social media company, or am I working with a smallholder farmer to solve the problems that they may be facing? That choice of stakeholder has huge implications for who gets to benefit from AI and whether we actually approach a just transition. In some ways, this is not so different from thinking about any project in the climate space, whether it uses AI or not, right? Who does it benefit? Who do you work with? Who is involved from the beginning and actually gets to shape how the thing looks? Of course, it's not enough to create a product and then way afterwards say, oh, okay, smallholder farmer, does this help you? This really has to be a participatory process from the beginning. But then in the longer term, then we need to be explicitly thinking about, well, how do we build capacity around the world to actually create, use, benefit from AI? Because fundamentally, as participatory as you get, if projects and solutions are only stemming from one part of the world, you will never, ever address all of the contexts and all of the kinds of things that need to be done. So it's really this question of, I think, capacity building is something that, in particular, policymakers, but also businesses, but in particular, I think policymakers have to really think about too.
So I'm really interested in terms of who that responsibility falls on. What AI, I mean, one thinks, okay, AI, how is AI developed, right? At least in my experience, AI is very, as you mentioned, objective specific, and there's different sort of tools that are being, designed for different applications. So I'm interested in knowing from your experience and from your sort of expertise and experience within topic, who is developing AI? Is it more, industry developing its own AI, or is it more academic? And is that academic world more focused on theory, on developing new tools, or on applications? I mean, maybe the AI sector is huge, right? And it's difficult to, generalize. But from your experience, where would you say is the AI developing happening? And also, I'll take opportunity on what latitudes, because sometimes, we cannot ignore the bias that could happen. You mentioned the global north, that they develop it, and then in Latin America we try to import these sort of technologies, and it just doesn't work. So some insights on that?
Yeah. And I would say that right now, AI development is happening among a broad range of players. So academia, industry, in the US national labs, for example, as well. And that it takes many different forms, right? So AI and machine learning, it refers to a very, very broad set of techniques, to very simple, regression models that you can run, like very simple models that you can run on your data, to sort of state-of-the-art models that are, really complicated and you work on large swaths of data, et cetera. So I think that there is actually a very wide range here. But that in particular, I will say that a lot of the sort of, cutting edge AI models, et cetera, these really are in some ways being driven by, as to your point about latitude again, right? Power entities with money and power in the global north to a large extent. This is not universally true. There are definitely institutes and individuals in the global south and developing countries who are doing really great work in this area. So I don't want to minimize that, but thinking about systemically, I think there really is this bias, and and that is an issue. And I think sort of categorically, even in the global north, I think there's a large extent to which smaller players or players with less money or power or capacity are not necessarily benefiting. So these are things like NGOs or local governments, et cetera. So it's not just a global north, global south issue. It's also thinking about within any individual context, again, who has power, money in society, and who is benefiting or not benefiting from these techniques right now.
So an interesting point there is, at least when we talk about energy transition, a lot is that sort of cooperation between public sector, private sector, how they work together. And there's great examples and horrible examples of how they haven't worked together, and really the potential that they could have leveraged if they would have worked together historically. And I'm interested to know, within AI, do you see that sort of collaboration between industry, academia, and public sector, or do you see them sort of still, apart, competing within each other? How do you see the sort of collaborative spirit within AI?
Yeah, and I'll expand the question a bit too, right? Because we're talking about, of course, not just AI, but AI for climate, which means that there's, of course, many, many different sectors that need to come together. So the question is not just, for example, is government working with the private sector, academia? The question is also, are the parts of government that are focused on digital innovation and digital transition, working with those parts of the government that are focused on climate change mitigation or adaptation or relevant sectors. And I think there are some places where this is happening, but I actually think in some sense the quote unquote, the what I'll call sort of the vertical collaboration within one subject area, but among different players, I think there are more structures for that than sometimes the horizontal collaboration between AI and different sectors. And this is incredibly important because it's not just about, right, there are ways in which AI can help with the energy transition or with climate. I think this is absolutely true. And in those places where AI can be helpful, hopefully it gets, used as part of the toolkit. But also the way in which we develop AI technologies as a whole has implications for climate, whether or not we think some of those things are climate relevant. So these are things like, AI being used in recommender systems that are then used for advertising, which increase global consumption. That has implications for climate change. We don't necessarily always think of that as climate relevant, but it is. Or things like AI's use in autonomous vehicles. AI is a key technology for autonomous vehicles. And autonomous vehicles, on the one hand, could be developed in a way that, entrenches the role of private fossil fueled transportation. But on the other hand, it could also be developed in a way that bolsters public and low carbon transportation. So there are lots of choices in technological development that have huge implications for climate. So I think the integration between AI and climate change thinking, it goes broader than just how can AI be used for climate, but also how can we think about AI as a whole in the context of how we approach global climate transition.
That's very interesting that you mentioned autonomous vehicles and the sort of vertical and horizontal collaboration, because at least in my experience, having worked with sort of connected vehicles with the objective of reducing emissions and making transportation more efficient, harmonization was a huge topic. How do we harmonize different initiatives, different technologies? Do we create sort of an open market where everyone can just chip in with their own technologies? But when we talk about sort of communication systems, we need to think of the wider implications on infrastructure, on sort of signaling, etc. So I'm interested in knowing how relevant is AI and harmonization, right? In the sense that what if my AI that I develop doesn't like your AI, and they come in conflict on the road, they cause problems in the power system, etc., etc. How important is it, and how can we regulate and oversee that?
Yeah, it's a really important question. And I think, right, like regulation, standards and standardization are also going to be really important. And then also human in the loop systems. I think often when people think about AI, they think about full automation. But even thinking about, for example, how our electric power systems are operated today, we think of them as, very engineering-y systems that probably a lot of automation is going on under the hood, and it is. But you also have control room operators sitting in the electricity, in the power system control room, monitoring the system, trying to get insights from their analytics techniques in order to then manage the grid. So this question of also like human in the loop and human integrated systems, and not just how do we fully automate a system, but where is it appropriate to also use AI to inform a human decision? I think that is these kinds of things are all really important. And so it's not just going to be, yes, if we create standards that, make a bunch of autonomous AI systems interact with each other, that clearly won't solve the problem. It's certainly, there's a human dimension to it too.
So definitely a human dimension to it. And a lot of voices are on, AI replace jobs. Have you faced, in your research, in your work, sort of a reluctance, a sort of attack against AI in that sense? Because, there's that job sense to it, right? But also there's a more philosophical side, and in the sort of automation and not fully automated is who takes the decision, the human or the AI? And I think that, slowly as AI becomes much more complex, that line is being blurred, right? Who takes that decision? Who has that responsibility? And if you can sort of walk us through of how that is happening within the energy sector, it'd be very, very nice.
Yeah. So I think the broader question, of course, AI jobs, it's a whole other topic, which we could do a full other fireside chat on. But I think, to give my quick opinion, suffice it to say, I think that those who think the problem is just technological as opposed to social political are often missing the boat. There are a lot of questions around what political structures do we set up to make sure that regardless of where things go, that people have livelihood and support and all of that kind of thing. But putting that aside and diving into the second question around like, how do you deal with accountability and who ultimately makes the decision? There's no, I think, like one silver bullet answer to this. I think in the electric power system, this has so far come down to what systems were already in place, which is where, a lot of human in the loop decision making is happening. And then where can AI facilitate the making of some of those decisions? I think in some ways, sort of more radical transitions are maybe imminent, maybe starting, but the question of, do we have a fully decentralized automated grid where different components are trading in, et cetera? I think we're actually very far from that. And there are a lot of people who are thinking about how do you design markets that are fundamentally designed around various aspects of automation. But at the moment, I think a lot of these decisions have been made very purely based on, what do organizational structures, et cetera, look like today? And how does AI integrate into that? And also, how can AI within those organizational structures help facilitate things that weren't possible before? Today, it's at least perceived to be difficult to run electric power grids with very, very large shares of renewables if you're getting upwards to 50, 60, 70 plus %. And AI can, in theory, help get us part of the way there by providing additional, monitoring, infrastructure optimization, forecasting, even within the way that systems are operated today, to provide additional insight. But there are differing perspectives as to whether that'll be enough. So a very circuitous answer to say, I think there's a way it's played out in practice at the moment, but I think the jury is still out in some sense in terms of both how automated systems will look and whether that requires then reinventing some of our systems of accountability or just adapting some of our existing ones.
So in that sense, usually I've heard AI, focused on sort of the execution, optimizing systems, making it better, more reliable, etc. And I mean, I'm trying to sort of bring the social side to it because I find it's super and every day more relevant when we talk about net zero and emissions and what are the implications of all of this. And I'm interested, Priya, in your experience in AI used to determine the impact of perhaps decisions on the wider power system, on perhaps specific groups of people, perhaps on the economy. How much AI is being focused on determining and measuring the impacts rather than just executing and optimizing?
Yeah, it's a great question. Maybe one thing I'll do is step back and try to give a bit of a taxonomy of the ways I'm seeing AI used in the climate change space as a whole. So I would say there are kind of 4 major categories that I see where AI is being used. So one is AI being used to gather information for monitoring, to distill large streams of information. So this is things like AI being applied to satellite imagery or sensors to understand where deforestation may be happening, or to monitor methane leaks, for example, or to analyze large bodies of text like policy documents in order to understand what trends one might see, things like that. So there's definitely a huge theme in terms of just distilling large sources of information in order to provide information for decision making that I'm definitely seeing occur in the energy sector, in forestry. It's happening in agriculture. That theme is actually insurance. Actually, is another big one. That theme is really taking off. Another theme is forecasting. And again, this is things like forecasting solar and wind power, but in the broader climate space, it can also be things like forecasting crop yields or extreme events, et cetera. And here there's a question of some of these things feed into automated systems, like a forecasting of solar power might feed into an automated optimization of a power grid. But things like forecasting of extreme events or crop yields may also then inform a city planner who wants to understand how to make their city more resilient to a particular climate-related event, or a farmer who wants to understand how to be more resilient. So these 2 things are really focused on the decision-making aspect. And then there's the optimization aspect, as you describe, right? So machine learning algorithms to optimize electric power systems or optimize supply chains, make things more efficient. And then also on this optimization side, there is the use of machine learning to actually accelerate scientific discovery and in the discovery of new clean technologies. So things like if you've tried to design, tried out several different designs of a battery, and you have some information about how those batteries perform, AI has been used to analyze the outcomes of those past experiments to then recommend, well, what battery should you try to design next, either because it'll give you more information about what might work or because this design will work. So this is sort of a system optimization, but it's again informing somebody. It's informing a scientist who may need to spend many months synthesizing some kind of material or creating some kind of technology in a lab and testing it out and hoping to sort of reduce the number of cycles that they have to take. So I would actually say that the ways I've seen AI being used are fairly broad in this space, sort of spanning, the like traditional optimization kinds of things, but also really sort of providing information for decision making, and also kind of looped into fundamental scientific and engineering discovery in the clean tech space.
So that's definitely very interesting. Considering my experience working with and for the public sector, this sort of the first step or the first stage that you describe of distilling information, of monitoring. My question is, okay, from monitoring, we can pass to reporting and verification, right? I mean, those are the sort of MRV that is commonly used. And there we need to be very sure about the data, how robust it is, how accurate, how precise. I mean, a lot of numerical, theory behind it that, having worked also with satellite image, I know how complex it could be to really ensure that the wavelength is a specific wavelength and not the other because of a cloud passing by, right? So I'm interested to know, how have you seen examples of AI used for monitoring and reporting and verification? Can you give us a sort of insight of where we're at in terms of the global context of, okay, methane leaks? I mean, that's a huge topic right now. How can we use it besides like the very nice reports that we get once in a while on Twitter that, there's specific methane in this location and not the other, etc. But for governments to really act on it, how far are we from acting based on this sort of AI results? It'd be very interesting to know.
Yeah, and I think there's sort of two different questions in there, right? So in what kinds of information is AI giving us that could be acted upon, but then how do we actually translate that insight to action? So in terms of the first side of things, I would say that one really good example I'd like to highlight is a coalition called Climate Trace. So Climate Trace is a coalition of organizations from around the world that came together to say, look, there right now is not a really good independent mechanism for monitoring emissions from different countries and different sectors. And we want to provide those third-party estimates, and we want to do this in a way that is fully transparent. So they used a combination of satellite imagery and on-the-ground data. They sort of released a first inventory of, based on our analysis, what do the emissions look like in these different sectors around the world, sort of updating old estimates, but also providing estimates that, where we didn't have data in the first place. And as you bring up, there's this question always of, how robust are these things, right? And I think the best you can do is, right, to provide your methodology, provide your data, allow people to audit it, to see it, to understand where there may be limitations, gaps, and keep iterating on it. And then also understand where some of the data collection is a stopgap, or some of the modes of data collection are a stopgap rather than the final goal. So, for example, to give a different example, there's been a lot of work using natural language processing to try to mine financial disclosures from companies who might be also disclosing their climate risk. And the reason this work exists is because a lot of these disclosures are just not in a tabular format that can be analyzed. So the short-term solution is, okay, let's use AI to mine a bunch of documents. The probably better solution that we should be working towards is, can we just report the data in a way that is able to be analyzed in the first place? So I think understanding also, where is AI and machine learning filling a gap where in the short, it's very important to fill this gap and fill this gap quickly. But then what structures is AI and machine learning the final solution, or should we set up structures that sort of put the AI and machine learning out of business because it was really a stopgap solution? So I think a lot to think about there. And then in terms of just quickly, like how you translate this into action, I think there has to be a really, a better integration in a lot of cases between those who are doing the monitoring and those who would actually use the outputs of that. So for example, you can do something like monitor methane leaks, but if that information is never sent to a policymaker, or if the thing that you're detecting is actually not useful at all because they have a great information about that thing and it's some other phenomenon in a different area that they don't have information about, then that monitoring result never gets used. So I think to an earlier point you made, I think that tighter integration between decision makers and technologists, academics who might be producing these things can help drive the development of the technology in a way that is useful, and also sort of ensure that from the get-go you have a stakeholder who will use these insights.
Mm-hmm. So you mentioned the concept of transparency, which, I mean, usually right now, at least in my day-to-day work, is really related to financial transactions. But in terms of the AI methodologies, the AI structure, assumptions, often I face, and for me, I see it very clearly day by day when I interact with public sector and academics or private sector. It's very difficult to describe the methodology behind it. It's very easy to get confused with sort of preconceived conceptions that we had since we were young, and it's really, sometimes they see AI and there's like a sort of pre-freaking out of, oh my God, they're gonna speak to me, a very strange language, and to a certain extent, you can describe it quite simply. So I'm interested in knowing, where does transparency fit in? Do you see transparency being a relevant issue as we go on with AI development, or do you see it like naturally occurring? How do you see that fitting in?
Yeah, so I think transparency does not happen automatically. And that there, have to be various incentive structures or regulatory structures that are set up to either inspire or require transparency in various places. So, for example, the EU AI regulation, the proposed EU AI regulation tries to specify, okay, for example, for high-risk AI systems, here is some information we want about this in order to be able to then both regulate that particular application, but also monitor the development of trends to be able to make better policy going forth. I think that is really important. And I think there's sort of, when it comes to transparency, I think there's also this question of what data is available and what data is communicated. So I think it's very important that, for example, if I am doing some work on AI and machine learning for power system optimization, that, a technical person can go find my models, my code, et cetera, comment on that part. But equally, someone who is a user of that system, who maybe does not know AI and machine learning, but cares more about the outcomes of that system, can focus in on that part. So I think the answer is not, okay, in every single policy meeting that you sit down in with a policymaker, they have to walk out understanding exactly how your neural network works. No, right? There's certain information that they will care more about and focus on, but that information should be available, right? So that different people who have expertise in different parts of the system can audit it, can understand it, and then also distill it for different audiences who may benefit from insights on different parts of the system. Yeah,
awesome.
And I think this point you mentioned about fear, I think it's very apt, right? I think that right now, AI and machine learning is viewed as a very, scary or special technology in people's minds. Things like engineering are not, right? If I say, oh, I used engineering to solve a problem, people say, okay. If people say I use AI and machine learning, people get very scared. And in some sense, I think what we should be moving towards is for, different players in the space to have, in some sense, as nuanced an understanding of AI and machine learning as they do of engineering, to understand it's a tool that works in some circumstances and it doesn't work in others. It has some limitations and some problems it can't solve. I think the more we can work towards that shared understanding, the better. And I think both there's a need for like capacity building education on the policy side, et cetera, but also on the AI and machine learning side to make sure that those who are working in these areas are able to properly communicate about what their work is doing, but what their work is not doing, and really make sure that we can sort of build that shared understanding over time.
Which is exactly what you mentioned before, right? Capacity building, a huge element when we talk about AI. To wrap up, I mean, you are in an academic context. You are pushing knowledge every day more and more, further its applications. You clearly see sort of the potential and where we're at right now to have a sort of difference, a delta between them. That is your sort of, I would assume, your day-to-day motivation. I'm interested in, and to wrap up, what would be your wish list of how AI unravels in the next years when we think of climate change, when we think of net zero? What are the main elements that we should be aware of that are happening, that are not happening, to sort of wrap up this session?
Yeah, and I'll give sort of two threads here. So one is on the AI side. So talking to those who are maybe practitioners or developers of AI, I would be very excited to see AI development that is fundamentally driven by the stakeholders and problems that are faced in climate action. So the kinds of methods you develop, for example, when you're looking at an electric power system where you have to satisfy various physics and hard constraints, are very different than the kinds of problems you face when, trying to mine Twitter feeds in order to, inform a social media company. So the way we develop methods is very informed by the types of problems that are central. And I hope that the AI community sort of centers both, again, problems in climate change, but also problems that are faced by smaller stakeholders with less data, who face different challenges than sort of the traditional or canonical stakeholders in order to shape the direction in which the field goes. On the climate change side, what I don't want to see happen is to have a bunch of people say, AI is a silver bullet, it'll solve all of our problems. That is not true, right? But what I do want to get towards is building, again, a shared understanding of AI is one part of our toolkit. How can we sort of make sure that it is able to be used in those places where it is relevant? And this means things like also thinking about, as we are for many other technologies, how can we open up innovation pathways in highly regulated sectors to make sure that we're able to actually try out things where they might be used? And also, how can we monitor them? How can we regulate them? How can we just understand that development? So I guess sort of keeping AI in mind, both how it can, what its potential is, and also how to monitor that is sort of the biggest thing I would like to see on the climate side. Yeah.
Priya, thank you very much for your insights. I think these type of sessions help us sort of disseminate and capacity build people and really the nexus between AI and climate. So thank you very much. It was definitely a pleasure and honor to be on the same panel with you. So I'm looking forward to future collaboration.
Likewise. Thanks so much, Andrés, and to all the organizers as well.
Thank you.
Priya, Andrés, thank you so much for this amazing conversation that you guys had. This was really enriching, and it has really important implications for the present and future of our planet. It was really interesting to learn from your experience, and especially Priya, to learn, and I agree completely with you, right? We have to center the conversation around the problems that really matter. And I think that the use of AI for net zero is going to be essential for us to make sure that we are mitigating those risks that climate change brings to the table. So thank you so much for this conversation again, and have a wonderful day. To all of you who are listening to us, please stay with us for the next presentation at this thematic track of AI for Net Zero at the AI for Climate Global Forum Edition 2021. All the best.